Hello my dear students. Today's lecture I am talking about Latin square design, which is also known as L.S.D. The topic is designed for the B.Sc 6th semester major students and C.B.C.S 4th semester generic students under Dibrugarh University. The learning outcome of this lecture is, after completion of this lecture, you will be able to know the basic characteristics of a Latin square design and the layout of a Latin square design, different types of Latin square design, merits and demerits of Latin square design. A Latin square is a balanced two-way classification scheme. This arrangement was originally presented through Latin letters, so the design is called Latin square design. When these letters represent some treatments of an experiment, it is known as Latin square design. Here, some properties of Latin square design. The number of rows, columns and treatments of Latin square design are all equal. Each letter, that means treatments, occurs once and only once in each row and each column of a Latin square design. Next property is that each row and each column is a complete block. Here, every row and column represents a complete block. A letter in I, J position also occurs in J, I position of a Latin square design. A Latin square with P rows and P columns is called a P by P Latin square or Latin square of order P. This is the layout of a Latin square design. A possible layout of 5 by 5 Latin square design is as follows. Suppose we have 5 treatments and they are A, B, C, D and E. And each treatment replicated 5 times. So we should divide the whole experimental area into 5 by 5, that is 25 plots. See, we have divided the whole area into 25 plots. Now the treatments are allocated according to rows and columns wise. That means here A occurs in the first row and first column. So A could not be occur in this row and in this column. Similarly, B occurs in the first row and second column, so B could not be occurs in this column and row, and so on. Here some important Latin square designs. First, I will define a standard Latin square design. A Latin square is said to be standard if the elements of its first row and its first column are in a natural order. So look at the following design. Here we have 5 treatments A, B, C, D and E. So the treatments, that means elements of this first row and first column are in natural order because these letters are occurred in natural order. Next is the conjugate Latin square design. Two standard Latin squares are conjugate to each other if rows of the one are column of the other. So, look at the following two Latin square designs. First, they should be standard. That means the first row and first column are in a standard way. And see, the rows of this square is column of this square, and see, the rows of this square, first square is column of the second square, and so on. So the two Latin square are conjugate to each other. Next is the self-conjugate Latin square design. A standard Latin square is said to be self-conjugate if its arrangement remains same when its rows and columns are interchanged. So look at this following design layout. When we change the rows and columns are interchanged, see, then the arrangement are remain same. So it is a self-conjugate Latin square design. Now the advantages of Latin square design. A Latin square design is able to control two-way variability, that means row wise and column wise, which is not possible in other designs such as CRD or RBD. So this design brings reduction in error mean square. Another advantage of this design is that the estimation and analysis of missing data is simple. Analytical procedures are also available for analysis of data when two or more rows, columns or treatments are missing. The Latin square design have also some disadvantages, and these are: Latin square design can accommodate a limited number of treatments, so this design generally cannot accommodate for more than 10 numbers of treatments. Also, another disadvantage is that a Latin square design for less than 5 treatments does not provide adequate degrees of freedom for experimental error. And another disadvantage is that a Latin square design of order 2, 3 or 4 may not be as efficient as a completely randomized design or randomized block design with same number of replication. Lastly, these are my references, and thank you for